Hello everyone. So my topic is going to be focused, as was introduced recently, incident response with artificial intelligence and machine learning, and towards OT, IoT, and Industrial IoT when it comes to attack detection and prevention. So my whole talk would be focused on two approaches, on two things, two main topics. First, on incident response and all the struggles and everything that those teams would have and challenges and issues, and we will give it a little bit of context. And the next part would be sharing some results of some research that was done on this field. So a little bit of myself. So I am a professor of the IIOT. I'm actually working at Commonwealth University of Pennsylvania in USA. So my whole experience and background is built on top of the information technology and then cybersecurity. It came to me within cybersecurity because I got my first certification from EC Council on CEH. So that was the beginning of the whole thing, entering this field, and then just enhancing more and more with persistence towards more expertise on industrial IoTs and IoTs. So that my whole experience, which you can later on check in on that. And I do a lot of research when it comes to the incident response and all those operated modes of wireless or wired networks when it comes to the IoTs and industrial IoTs. Let's give us some context within this topic. So the challenges that those OTs and IoTs would have are all kind of different. So massive device scale, so a diversity of all those devices that manufacturers produce is huge, and even the communication standards like protocols and everything, and structured and unstructured data formats, all those kind of things will just pose challenges when we operate with those infrastructures, huge infrastructures that would be composed by IoTs. So, and vendor fragmentation, and then all of those things coming from manufacturers is producing a lot of lacks and gaps when it comes to the security. So when it comes to computational power, very limited, I could say, restricted resources. We know that sensors will not be able to process a lot of encryption and decryption process, so we will not be able to apply some kind of cryptography on that. So, and hard to patch. All those challenges and issues are very serious when it comes to the incident response and management and handling all that process. On the other side, we have threat actors. We have risks, threats coming from attackers, APT groups, whatever it was, that they were trying all the time to have that kind of race, winning within a time with us to exploit more vulnerabilities in those devices. And we know that part of the vulnerabilities would be groups of misconfiguration, which comes by the manufacturer design itself, and then later on by the user, company, organization, that they just inherit that kind of security and they are not so much adjusting that towards a better one. And then the rest would just be part of the protocols, channels that we use to communicate, and all those would include a lot of issues when it comes to the threats and risks. Let's see further. So incident response have a lot of issues and a lot of struggling obstacles. So incident response teams are facing those called data blind spots in the cases of industrial IoTs, OTs, and IoTs. So logs would be incomplete sometimes. APIs would be missing, and every vendors would behave differently. So we would have very limited visibility, so we would not be able to cover the whole infrastructure sometime, and having all that monitoring set up in place and seeing every part of infrastructure, because we might have an edge devices, edge gateways, edge infrastructures, not just those that we have within a facility, and distributed devices all over the place in the field of operation within the facility. No centralized logging, so all those devices would be attached to that network, and all those might produce different loggings and potentially those might not be stored within a centralized same place where we would be able to attach a CM solution. So we would have that 365 degree of whole what is going on. No standardization, we said that every manufacturer would produce its own design when it comes to the firmware of those sensors, standard protocol communication, and a lot of things. Difficult triage, of course, we could have a lot of false positives, alerts that could struggle us with this. Slow containment, so all those would be bringing as pain points for those incident response. Let's see further. So threats would keep growing, of course, all the time as technology evolves, and even with AI that we very utilize today, those threats are just advancing and advancing in methods, techniques, all kind of attacks. So industrial IoT threats are no longer a theoretical part that we can just tell the stories, but attackers were moving beyond that kind of reconnaissance into more disruptive into targeting those industrial sectors by using, you see here, there are a lot of threats that already happened over the years, and this list is endless, and all those are targeting exploitation towards those IoTs and industrial IoTs. And a lot of actors, for example, CISA, is providing a lot of guidance and regulation, trying to provide more resources when it comes to the tools about industrial IoTs and industrial control systems. So ICS, industrial control systems, they have exposure on the internet. So it's very easy for us to find that and to see and experience that. We might just go over the platforms that they provide, for example, shutdown.io, which you will see here too, a screenshot that is showing a lot of issues when it comes to the IoTs. And we see that there are a couple of protocols like Modbus, DACnet, DNP3 that they have been publicly exposed. So that would bring us a lot of facts and evidence that this is for real, and we will need to tackle this and to do something with all this technology evolvement that we already have. And reality. So we would be reality on incident response, so cannot keep up. We have a lot of things. So manual incident response cannot handle the volume of this kind of complexity that we just saw on industrial IoT environments. So this would lead us to much better utilization of technology, for example, AI and machine learning, which I am teaching that a lot within the courses for my students. So too many alerts, too many assets, not enough analysts, not enough expertise, and slow detection, slow response, and expensive recovery. No matter how much people you would have on the team, you would struggle. So and with that AI would not be able to replace humans, especially in this incident response at some levels, but not the whole thing. So it gives incident response teams some superpowers, and why not using some? Why AI detects unknown behaviors, handles massive log volumes, learn patterns, reduce noise, false positives, and all about the other noises that you might be facing within those logs, and accelerate triage. So within each of those steps, we would be needed a human behind that to decide, should we move further with that direction or with that? The other one that would be needed to make some kind of decision. For that, we have a machine learning, which is a quite long time around, and we can utilize a lot of algorithms when it comes to that. Let's see that. So the next part, I'm going to jump to the second part of my presentation, my talk, into the research. So in the beginning of 2023, I started engaged on a research project, which I was part of the ICT Academy, which is an ATC of EC Council, and providing a lot of training for EC Council in different parts of the world, on Europe. So, and then I got a research project leading for, in cooperation with Global Cyber Alliance, GCA, and we got a data set that we needed to figure it out what was the issue and try to come up with a model by using machine learning that would be able to distinguish and identify a lot of attacks, threats, and risks that you can find. So those data sets would be generated by their honeypots that they have already set up. So on the data set that we would be having a lot of IoT attacks, logs, login events when it comes to commands, protocols, and geosource. So we would be able to know even the real source, geolocation, source, geographic location, where that was coming from. The whole research was based on data science lifecycle, which you see that are divided in two parts, in two phases. The first, understanding all about the data and everything that comes from the data set and prepping those for further processing in utilization of machine learning algorithms. And we made that. So we understood, we made the model design, and we had some results, some behavior of those models. Let's see. So we did this EDA, exploratory data analysis, which would give us a lot of understanding, and we were doing a lot of analysis when it comes to this data set, and repeated attack. What was found as an outcome of this process was repeated attack credentials, strong attack patterns. So we found out that there is a pattern, and 23.4 million of successful logins attempts where username and password was used as a success access, and most of those were default credentials, those that we would inherit from manufacturer by design, that they would sold you and sensor and router and whatever was that part of the device that would operate as an IoT, and that would be, you would just inherit that misconfiguration we would consider from cybersecurity, and that was exposing a whole 23 million successful logins attempts within this data set, which was a real one. And then to the conclusion, so there were some common vulnerabilities, especially in the logged in field. So we saw a lot of successful logins attempts. The whole total data set, and a majority of it, almost half of it, was because of the username, default username and password used. And certain login credentials were more common targets for attackers. And many attempts do not successfully use or capture credentials. So those were kind of conclusions from this phase. Next, we see a lot of graphics, which you can deep dive more later on if you want it. So we have fields and values. In the first one, we have the login field, which is kind of significantly lower counted in that total half part of the majority of the data set, where indicate that not all attacks attempts were successfully, so that's kind of a good positive side. In the second graphic, so high number of unique values means that emphasizing the dynamic and diverse nature of the IoT attack landscape, so was broad. Low number in unique values, signifying that specific logging combinations are tried repeatedly. So that means that someone tried the same kind of combination towards this target IoTs many times. And the third one would show high frequency, the most common successful logging. And we would see that on credential, that combination that was used, suggesting that a commonly exploited vulnerability. With this result, we understand that we have an issue in front of us that we needed to solve when it comes to the security. Features extracted, model design, and model development. So we went further on that one. So we selected a certain type of fields that was suitable for our research, and then further choosing algorithms within a machine learning. So we used the supervised one, and we would deep dive more on training set and testing, where we would be having some metrics measuring the whole model behavior. So this was the behavior, and it shows that the accuracy, all those metrics, precision, recall, F1, and AIC scores would be in very good high levels, which shows that those behaviors of these machine learning models would be able to effectively and correctly identify and predicting IoT attacks with very minimal false positives. So that's good. That's one good metrics. The second one would indicate that would show us that models is well balanced. We check that, so both in identifying attacks and minimizing false alarms. And other implication to IoT security, what it is. So such models and more models that are coming with those good behavior metrics showing the results would enhance the whole security of the IoT. Why? We said that this is just you showing some facts that this could happen and we could enhance and have a better security when it comes to those infrastructure by utilization of actual what we have. Machine learning, AI, and cybersecurity would just be enhanced as an outcome of the utilization of those two technologies within an incident response. We would see that further with the real facts. So what this would mean for the incident response, so even slight improvement, those teams, those organizations that would handle incident response would feel that improvements in prioritization dramatically would reduce analyst fatigue. So we would have much faster detection, lower false positives, a desired state of every cybersecurity professional, behavior-based alerts, prioritized triage, and predictive analysis. More and proactive approach rather than sitting and waiting that something to happen. Integrating machine learning into the IoT world, so we prototype models that would be plugging into SIEM, case management, or threat intelligence workflows like MISP. So all those could be used for further detection enhancements when it comes to the logging brute force, geodistance anomalies, common spikes, and so on. Recent thing that I'm working beyond those research is trying to prototype cybersecurity by design. So providing this prototype as an industrial device when it comes to the real-time learning on anomaly detection, utilization of machine learning, and considering edge and cloud hybrid continuous learning and more industry-ready form factors. So what you would use as a part of this architecture, I name it IoT Guardian, would be that covering all that data flow from sensor gateway to the storage where the data would rest. We would be covering this by utilizing the technology of machine learning, and then that would just make that prediction analysis on top of those data set that would be tested and trained, and then that would be very easily included as an algorithm or as a rule within any SOC or CM solution that could bring a more automated response possible. But you might be saying that with this you said you are gonna move a human factor from that whole equation. That's not true. Let me show you more on that. So that's a part of the work that is just coming, is ongoing. Other research models that I worked and I already hold patents are those that I work mostly on the wireless sensor networks model, where I was trying to have better model on network level attacks. So that would be identifying and detection on WSN, those on wireless sensor network, different attacks when it comes to the network level, like sinkhole and those typical attacks. And then further on, different sectors on the smart transportation, where we would have prediction of a traffic model, sinkhole, wormhole, kind of a WSN algorithms. And recently, I'm working on those IoT edge cyber attack model, where I'm trying to adjust and have a better model when it comes to the health sector, health organization. That would mean that whole governance on security when it comes to the data patients and a lot of things that could happen in health sector, as we know. Further, so AI for each incident response phase. Examples. This is a typical example that we're gonna still need people within a SOC teams. So on the other side, in one side is AI-driven triage, where you would have all those facts, that data that could be useful whenever we would be utilization. We would have utilization of machine learning and AI. On the other side, you have an incident response phase. So we know we have detection, and enrichment correlation. We sit and do triage, we filter what we need, what not, dump it, containment, recovery, come back in our feed, and lessons learned. So going from that, so for example, before machine learning, without utilization of any of those technologies that we already have, that means that 10,000 alerts per day. Imagine that for that whole SOC team, incident response team, going all over those alerts daily, that is devastating. And then after the utilization of some machine learning models, anything that would be just behaving in very lower percentages of the metrics that I already showed, imagine high, those very well trained, would mean that top 5 meaningful alerts. So detection on false positives could decrease that number from 10,000 alerts per day. And then behavioral scoring so would mean that model would be able, as you know, to predict and analyze that all behavior when it comes to behavior, repeated attempts, tried many times, and a lot of things based on algorithms that you trained. And then 92% of noise reduction would happen immediately with this first step. But again, we were going to need for humans at this point where that further, we're going to need to treat those 50 meaningful alerts and not just having 0. We could not bring to 0 that one and to hold process for the whole process on the models of machine learning and AI. The whole blueprint for more enhanced incident response with technology utilization. So we would know that SOC needs are asset inventory as much as they can within an IoT and OT, logging maturity, data pipeline, more data paths that are coming in our systems, collection of logs, machine learning model integration, automated playbooks, and continuous retraining of those. And those needs you can very easily accomplish by those tools that I listed, some of those that would be tools for implementation. So coming from the main platforms that are for utilized by the SOC, and then more onto those machine learning algorithms like Colab, TensorFlow that are used for prototyping, and lightweight edge devices. So practical guidance for defenders, challenge and limitations need for hybrid approach, AI plus human factor. So AI would be that powerful, but would not be a magic that would be with a wand solve all of our issues. The future of AI incident response will be more, we would be able to see more on those directions of autonomous agents, continuous self-learning, digital twins for OT, so we'll be able to mimic that whole physical world within the digital one by using digital twins approach. Predictive maintenance and security fusion, not just waiting to see things happen, but engage them, proactive, and AI-powered industrial control systems, honeypots, which would be very good utilization when it comes to the luring those deceptive technologies, luring attackers and threats and risks towards something that would be not important for us, and we would be keep away from this primary that we have. Some of the key takeaways of Industrial IoT's incident response is breaking under complexity, so AI and ML drastically would strengthen the detection and response. Research results proves that work at scale, so that prototyping in more some cybersecurity by design, which would be my engagement for several months later on, would brings it into the real world. So collaboration would accelerate that impact. Collaboration among academia, industry researchers, accelerate model accuracy and adoption as something that EC Council is doing. So that is bringing all of us together within those meetings and webinars, which is a very good one. So that was all of my talk that I wanted to cover. So if you wanted more deep dive, you can watch this whole presentation talk that I was giving on or reaching out to me, that I would be happy to discuss and see if that would work on any kind of work that we would be able to provide some good value to this cybersecurity when it comes to the industrial IoTs and OTs. Thank you. you would handle that much that you would be considering as important for you. So it depends what type of organization you are, what kind of sector you're operating. If that's a more sensitive sector, you might be increasing that threshold that you would be holding onto AI and models and AI as technology at some certain levels. But that would depend on the data, as we know that from the frameworks and standards. We depend what kind of data we are managing, we holding, and what kind of sensitiveness and impact would have if those would be threatened and exploited. And then you would decide that increase that threshold or decrease. You would utilize those technologies for having a better cybersecurity when it comes to the detection. So you would have a lot of data logs coming to you, and then you would be having those, and just having those, that would not be enough. And with the human factor, you will not be able to reach the end of all those daily data and logs that you have. So you would just speed up the process of going to the end of all the daily alerts and whatever you have. And that would just, then later on, you can engage more on risk factors. So you can do risk analysis on top of those, or cost benefit analysis, which would be giving you much more outcome and facts that you can later on bring that on data analytics, where you can build a much better models of automated incident response from that process. So in the same time, you can get that the logs and data and everything alerts and make that detection happens with actual whatever you have model. And then in the same time, you can do that for continuous learning and enhancing your own model with your own data. That's a perfect story for every AI model, that to being able to use their own data and to increase the sensitiveness on and detection levels when it comes to all those threats that would target us. Yes, deploying things on a real environment, production environment, is whatever environment is a struggle, it's a challenge for every project manager and every system administrator and cybersecurity professional. So I know that I had experience on that side, but most important, those AI solutions would on cybersecurity when we would be trying to apply and implement into the industrial sectors, would be those very old systems, OT and SCADA systems, which would be impacted by all those. But you can make this, turning this in other ways. So instead of touching and impacting the real infrastructure that you're already running, whatever it is, IoT, SCADA, OT, whatever it is, industrial IoTs, you would leave that as it is. But at the end, you would try to work on the rest of the infrastructure, where you would be towards gateways, mostly brokers, those places where we would be collecting all those data that are coming from sensors, but at the same time, we would generate logs. So try to see on different direction, and from that point, we would be able to have that as much as we can, feed those models with those data that are coming in logs from the gateway points. Or you can do that, you can design those kind of scripting models and functions in those gateways to collect as much as they can, and do not let any of those feeds to get lost or run any cycle of restart or reset or whatever, or dumping. So we are talking about volatile data. When it comes to digital forensics, that's very important for investigation, but at the same time for cybersecurity issues that we are going to have. So try to work on the rest of the infrastructure when it comes to that. Gateways, servers where we hold data, or cloud platforms where we would be just dumping those for later use. Yes, when I was doing those recent research, I went up reading a lot of other authors, and the work that was done, very good. Everybody is engaged in this fields of cybersecurity for IoT, OT, and industrial IoT. When it comes to wireless or wired infrastructure, doesn't matter. All those are engaged in providing a lot of benefits when it comes to economically. So one of the good measure that we can measure this is cost benefit analysis, or CBA. That would be something as security professionals that you can utilize an analysis on top of your outcome results, and the data that you are handling and managing within your infrastructure, within your organization. What you would do at the end of the day, you would have metrics, you would have some values that would be closing the day, so 10,000 hours per day done within a day of business hours, and came up with treating and triaging and closure of all those incidents, cases when it comes to solution, more digital forensic investigations that you would do. You would have all those metrics, and you would use all those metrics to run your cost benefit analysis when it comes to the economic benefits. But I am sure that from what I experienced and saw and implement those models and tested through, that those would just bring much better benefits when it comes to the economic value. So would decrease a lot of cost that would goes around trying to find any type of third-party solution that could solve your issues or help you, support you within a process that you are doing, managing, monitoring the whole security of your infrastructure. But benefits are all over. You can use this. I just gave an answer for using the mechanisms that you can further see that for your own, and that depends on the case that you would have. So there is no strict something that I can answer with some real economic benefits, but the economic benefit mostly would be that would decrease the cost of your investments on looking on third-party solution, since you already have that. You have the data. We know that when you have the data today, that's a very powerful, so that you would be able, logs and real sense of data, you would be able to build all these cybersecurity enhancements on top of that infrastructure that you're already operating. You just need to use those what we have. So we are not finding a magic thing that is not around, but I'm just giving you, what I covered was all those type of things and technologies and mechanisms and controls that we already have. Yes, that's a good point. So I'm in prepping for CISO, EC Council exam. So I was hearing there a lot of video lectures that the instructor is giving to us, and a lot of material that EC Council is delivering and bringing to us all to hold this community, is that those honeypots you can custom build workflows and things. So you would give it so much power and responsibility to mostly administrators and developers and designers to work together rather than typical cybersecurity people. So you would be able to mimic that whole infrastructure that you would have within a honeypot that would bring something that would lure the attacker, which within it would have dummy data, but pretty real dummy data. And that you could mimic that by using this well-designed logic by what you have. So if you would be a manufacturing company, you would design that way your honeypot, and there are a lot of honeypots from open source to the other ones that you can mimic what you actually have. So potentially you would use kind of the same infrastructure and structure within that whole honeypot that would be mimicking your real and primary environment. And that would be hard for those threat actors, APT groups, attackers to differentiate which is which and where I am to. So I'm not so much familiar with those honeypots, so that's not part of my expertise. But I know that from all those that I'm hearing talks and expertise from experts that has been leading those cybersecurity programs, they came up to this as an outcome, as a benefit from a work of administrators that they know very well infrastructures, developers, how they know very well how to build things. So you would just need to have that needs and requirements to fulfill by those two different roles, and then you would have a well set up lower deceptive technology by using honeypots that will lure more attacks towards something like sinkholes or mimicking that kind of real environment. So instead of you having honeypots, just web application, have there some sensors. So you can run them very easily. Utilization of the Python scripting would give you a lot of benefits. Very well, I found myself very well equipped with knowledge at the moment thanks to EC Council, for me, that was my story. So in 2013, I got into the training for CAH in Netherlands. So there I got an exam and I was certified. And from that point, I just continued further and further and further. And then I became an EC Council instructor. So thanks to that, there was a lot of resource and knowledge provided to me from EC Council to the whole community and even me too. And then now I'm pursuing that career that would be bringing me potentially, I hope, passing the exam on CISO that will be putting on the governance level when it comes to cybersecurity. But I would suggest you persistence. Persistent within this field, creativity, and love the things that you would do within this field would be that motivation that would drive you further. But do not stick in just one program or something. Try to see things from different vendors. In this case, EC Council might be something that I found it myself very suitable and equipped me with very good knowledge, which was I built on top of that my whole this expertise and with specifics towards industrial IoTs and IoTs. So that whole data science life cycle is the framework within steps, within all that research that you would do that can produce any model, just cybersecurity. But first, you would explore that business. So you would have someone that's needed something that needed a model for their cybersecurity detection, identification of threats and risks and attacks. And then you would be familiar with that business first. And second, you would deep dive more on data sets that you understand. Understanding that would lead towards the ending of the first phase, which is exploratory data analysis, very scientific way, where you would do a lot of analysis on top of those data. And that is because you want to understand the data. As you would know, data analytics and data science people would first understand the data. Whenever you understand the data, that you would know how to prep your data, prepare for further processes within a second phase of data science life cycle, which is choosing and selecting proper machine learning algorithms, train and test those models and see what those would be. So this would be the main steps within all this framework and the process that you would be doing. And the most would matter the data. So you want to make sure that you have good data, you prep good. When I said data preparation, that means standard form converting. If you use the algorithms that would be binary algorithms, you would be doing that data preparation on that way that you would be able to distinguish what would be that binary format and not having something else. So that would mean and all about data type, and then you would just use that algorithms that you would do those training and testing. That's a process that would take time, depends on the data and your computational power, and then you would have the results. So this would be mainly 5-step process within this whole framework of data science. So as I said, that would bring us a lot of benefit. Mainly, you would start your day, you would be in incident response team members, and there you would be having a lot of alerts coming, and you would be monitoring and handling that whole process by seeing how your model would behave and would be able to detect false positives, those doing a triage at the same time. But you would be there because you would need to be there to recognize and know and be familiar with all those that your model is doing and not is missing anything, because we know those models would be behaving, if those would be behaving 100% in all metrics, that's not normal, that's not good. We can do that very easily. We can prepare data in that way that model would be able to detect 100%, but that's not the desire that we want to have. Those would behave in some certain level of percentages, 80, 90, so that would be the levels that we want to have, that kind of model. And then you would be seeing that with your own eyes, and you would be feeling the experience that your model, what is doing within whatever that is part of the rule within a solution or platforms, all the sub-teams, or that would be a separated model that would be utilizing an application that was built on top of that would help you to distinguish. Or later on, So you're not doing, so there are a lot of approaches that you can do. You can do an approach within an incident response team, infrastructure environment there immediately. Whenever the data feeds are coming, you will do that immediately in that moment. Or you can do later on with the data scientific team, data analytics team, where people would sit down and analyze data as those would come and would be that those kind of two different approaches would be. But most helpful would be that would decrease your stress and everything that you're having issues, challenge to figure it out. What was this alert? And until you have another 1900 alerts that are just waiting for you for the rest of your day, to keep you busy and figure it out. If this would be suitable and valuable to further investigate, or we would just dump it part of the process of triage. There, you could look up, depends on the location that you would be. So if you would be on European part location, you would be looking on EU. They have many projects that you can find very easily. You just need to browse and Google those in those resources that EU is providing, or ENISA is a very good agency that provides a lot of regulations and guidance on that way. If you would be in US, I would suggest specific for industrial controls system for industrial IoTs and those things, CISA. So that would be the agency, federal agency that provide a lot of things, resources, valuables when it comes to fraud and all those things. And then in US, you would have more. You would have FBI resources, federal agencies, NIST would have when it comes to the frameworks and standards. Typical those resources would be that I would check mostly for those fraud detection. And then depends what kind of field, what kind of sector, finance or health or whatever. And depends on that, you would be sharp. You would be crafting your search towards a specific that would be related to your work that you're doing. First of all, if you want to utilize this technology, machine learning, then you will need to have the data. So data would be that core or everything, starting from that point. And then as a matter of tools, you just need an environment, an IDE, whatever operating system it is, Linux, Ubuntu, Windows, whatever you're using, laptop device, servers, that doesn't matter so much. And you would need to be familiar with those scripting languages, most important Python, that would be, and then be familiar with those algorithms of machine learning. So you would know which one would be binary, what are the distinguished categories, groups of supervised, unsupervised machine learning. Take one of those training and resources that you can find on the internet all over, and then practice within your environment, within a lab, and then use this data science lifecycle that I already showed. So find a data set. There are a lot of open source data sets that you can find within the internet, a lot of resources. Have the data set, understand the data set, the data, what's that about, and then figure it out what you're going to do. Put a problem in front of you, what I'm going to solve, and then further on, select the proper, or maybe you would do some analysis where that would be giving you more understanding of the data, and then try to find which model, which algorithms of machine learning I'm able to use for this specific data. If those would be distinguishing, would be more going towards binary algorithms, you would choose that algorithm that is suitable for that, and you would prepare data on that way that would have two values only. And then you would be running training and test, and when you run the test, that you would see what that models would behave, and those metrics values what it would show, and then you would know if you would be in the right track, if that would fulfill your objective and problem that you want to solve. But that would be with interpretation. So you need to be able to interpret those values, those metrics of your models. Yes, you can do a lot of testing. So you can decide as an organization, as a team, to utilize the machine learning and have that model, and put that side by side of your whatever you were running before and after. As I said, you can see those values, you can see the facts, and then you would decide, and you would see within your own, you would experience on your own, and you would see which one would feel right and would have a better efficiency and would save time to your team, instead of your team scrolling every alert and try to figure it out what's happening, what's going on. even with all those actually SIEMs platforms that we have, you would need to deep dive more on each of those alerts. Instead of doing that, your team would be busy on much better activities, which would be bringing a better decision when it comes to the resolution of all those findings that your model is bringing to you. So instead of going into that engine and working with engine together, leave the engine works on its own and utilize those whole technologies that we already have, those awesome technologies, and then you would deal with that outcome that would bring you. Of course, you would do recheck and balance of all that machine learning models. As we know, there are a lot of things that you would need to maintain that integrity and security of that model and the data that will be fed up on that model. But you work with that outcome, and your team would have much more time to think about creativity and a lot of things that would bring a much better environment and a feeling of that team that they are doing the right work, and you would just increase the efficiency to the very highest level of productivity of what you're doing. You would be maintaining much better cybersecurity for your whole infrastructure. Thank you very much. Thank you to the EC Council for letting me giving this talk to all of you. I would say that persistence in this field is very important. Do not stop. Move it, and doing progress and learn as much as you can. EC Council provides a lot of resources when it comes to expanding knowledge and increasing your expertise on different career paths. From those beginning and basic things when it comes to cybersecurity towards the more handle all those incident management and finding those penetration testing or security analysts, and towards the highest levels of governance security program. Thank you.